What's up, everyone? In this video, we're going to be finding the x-intercepts of a parabola. So if you missed my last video, I did the y-intercepts, and you might be wondering, why did I do the y-intercepts first? Well, because they're way easier. So let's do the x-intercepts now. So if I just graph a parabola, the x-intercept, just like with any function, is going to be where my graph crosses the x-axis. Now, this can occur in a few different ways. So let me draw all three cases. So the first way, I have two solutions, two x-intercepts. In this one, I'm going to have one y-intercept. It's going to look something like that. Oh, I said y-intercept. I meant x-intercept, sorry. One x-intercept. And then over here, oh, that's still a parabola, but it has 0 x-intercepts. So for this video, I'm really only going to deal with these first two cases because it doesn't really make sense to find the x-intercept if these are called imaginary roots. We're not really going to worry about that case too much in this video. So we're really going to focus on these first two cases right here, 2 x-intercepts and 1 x-intercept. Alright, so let's look at this first example. Let's say f of x equals x squared plus 5x plus 6. Alright, so to find the x-intercept, what I do is I just set f of x equal to 0 and solve for x. So what that really means is I take 0 and I plug it in right here, right? I make f of x equal to 0 and I solve for x. So what that looks like is 0 equals x squared plus 5x plus 6. Now, this is a quadratic equation. It's equal to 0. I want to solve for x, so I can just factor it. Now, the way you factor this quadratic is x plus 3 times x plus 2, right? 3 times 2 gives me 6, and then 3 plus 2 adds to give me 5, so that works. And that's going to give me that x plus 2 equals 0. Whoops, let me just undo that. 0, and that x plus 3 equals 0. So this first equation gives me x is negative 2, and the next one gives me that x is negative 3. Now, so if I were to graph that, it would look something like, so we have negative 1, negative 2, negative 3. The x-intercepts occur at negative 3 and negative 2. Now, I look at the coefficient of my x squared term, which is a 1. Right, so that means that it opens up. So it's going to look something like this. And this isn't a perfect drawing. All I care about really is the x-intercepts occurring at negative 3. Oh, I just did green on green. Occurring at negative 3 and negative 2. Alright, let's do another one. Alright, so for this next example, let's look at the function f of x equals 2 times x minus 1 squared minus 8. Now this is what's known as the standard form. It's kind of pesky and annoying to deal with, but we're going to get through it. So we want to find the x-intercept. So I set f of x equal to 0. So I have f of x, or I have 0 equals 2 times x minus 1 squared minus 8. Now this is slightly different from the last example because I can't just factor this, right? This isn't in, ax squared plus bx plus c form. This is in standard form. Now what I can do is solve this using the square root method, which is in another one of my videos. So if you're not familiar with that, go check it out. Now what I'm going to do is try to isolate this x minus 1 squared and solve that way. Okay, so what I'm going to do is I'm going to add 8 to both sides. So let me use a different color here. So add 8, add 8. So that's going to give me that 8 equals 2 times x minus 1 squared. Now I'm going to divide by 2. And that's going to give me 4 equals x minus 1 squared. So I've isolated my squared term on one side. So now I do the square root of both sides. And remember that that comes with a plus minus attached to it, right? When I solve an equation of this form, I have to have this plus minus right here. And then the square root and the square cancel each other out. So I'm left with, let's bring this up here. I'll draw a little line to separate this. So the square root of 4 is 2, so I get plus minus 2 equals x minus 1. So that gives me that plus minus 2 plus 1 equals x. Right, and this really gives me two different equations here, one with a positive 2 and one with a negative 2. So that's going to give me that 2 plus 1 equals x, and negative 2 plus 1 equals x, which means that x equals 3, and x equals negative 2 plus 1 is negative 1. So these are my x-intercepts. So on the graph, I have negative 1, 1, 2, 3. It'll look something, negative 1, 3, something like this. Right? My graph crosses the x-axis at negative 1, which occurs right here, and at positive 3, which occurs right here. Okay, well that's finding x-intercepts for parabola. Just a few examples. There's a ton of ways you can do this, especially for the first example. You didn't have to factor it. You could have used the quadratic equation in order to find those roots. It just depends on what you're comfortable with. I noticed that I could factor it super easy. If you can't do that, the quadratic equation, or the quadratic formula will always work to factor a quadratic. Now, for this particular example, it's a little bit more difficult because it's not in that form of ax squared plus bx plus c. It's in this standard form, which makes it kind of easy to do the square root method, but you know, it really depends on what you're looking at. If you have any questions or want to see some more examples, just let me know in the comment section, and I can, you know, whip up a few extra videos on this, because I know it's a little confusing knowing when to use what method, how to solve them, how to factor, all that kind of stuff. So just let me know, and I'll try to help you out. So thanks for watching. Bye.